Starting with the M101 variant, nuclear, biological, chemical protection was provided by a turret overpressure system. Previously, the Abrams crew had been required to don NBC suits in case of an NBC attack. NBC masks are still retained as a backup, and crews often train while wearing them to remain proficient and combat effective in such a scenario. Tank Urban Survival Kit, Edit. The Tank Urban Survival Kit, TUSK, is a series of improvements to the M1 Abrams intended to improve fighting ability in urban environments. Historically, urban and other close battlefields have been poor places for tanks to fight. A tank's front armor is much stronger than that on the sides, top, or rear. In an urban environment, attacks can come from any direction, and attackers can get close enough to reliably hit weak points in the tank's armor or gain sufficient elevation to hit the top armor. Armor upgrades include reactive armor on the sides of the tank and slat armor on the rear to protect against rocket-propelled grenades and other shaped charge warheads. Abrams Reactive Armor Tile, ARIT, consists of 32 XM19 reactive armor boxes added to the sides of the tank. ARIT-2 consists of rounded XM32 reactive armor tiles mounted over top the XM19 tiles. A transparent armor gun shield and a thermal sight system are added to the loader's top-mounted M240B 7.62mm machine gun, and a Kongsberg Gruppen remote weapon turret carrying a 12.7mm .50 caliber machine gun, again similar to that used on the Striker, is in place of the tank commander's original 12.7mm .50 caliber machine gun mount, wherein the commander had to expose himself to fire the weapon manually. An exterior telephone allows supporting infantry to communicate with the tank commander. In August 2006, General Dynamics Land Systems received a U.S. Army order for 505 Tank Urban Survivability Kits, TUSK, for Abrams main battle tanks supporting operations in Iraq, under a $45 million contract. Deliveries were expected to be completed by April 2009. Under a separate order, the U.S. Army awarded General Dynamics Armament and Technical Products, DATP, $30 million to produce reactive armor kits to equip M102s. Tiles will be produced at the company's reactive armor facility in Stone County Operations, McHenry, Mississippi. In December 2006, the U.S. Army added counter-improvised explosive device enhancements to the M101 and M102 TUSK, awarding GDLS $11.3 million contract, part of the $59 million package mentioned above. In December, GDLS also received an order, amounting to around 40% of a $48 million order, for loaders' thermal weapon sights being part of the TUSK system improvements for the M101 and M102 Abrams tanks. Active Protection System, EDIT. In addition to the armor, some USMC Abrams tanks were equipped with a soft-kill active protection system, the N/VLQ-6 Missile Countermeasure Device, MCD, that can impede the function of guidance systems of some semi-active control line of sight, SACLOS, wire and radio-guided anti-tank missiles, such as the Russian 9K-11 Forschum, and infrared homing missiles. These were not ready in time for the Gulf War. The MCD works by emitting a massive, condensed infrared signal to confuse the infrared homing seeker of an anti-tank guided missile, ATGM. However, the drawback to the system is that the ATGM is not destroyed, it is merely directed away from its intended target, leaving the missile to detonate elsewhere. During the Iraq War, the U.S. Marine Corps equipped its M101s with an VLQ-8 electro-optical jammers. In 2016, The U.S. Army and Marine Corps began testing the Israeli Trophy Active Protection System to protect their Abrams tanks from modern RPG and ATGM threats by either jamming, with ATGMs, or firing small rounds to deflect incoming projectiles. The Army planned to field a brigade of over 80 tanks equipped with Trophy to Europe in 2020. It is planned for up to 261 Abrams to be upgraded with the system, enough for 4 brigades. In June 2018, the Army awarded Leonardo Doctors, U.S. partner to Trophy's designer Rafael, a $193 million contract to deliver the system in support of M1 Abrams' immediate operational requirements. U.S. Army M1A2 SEPV-2 Abrams tanks deployed to Germany in July 2020 fitted with Trophy systems. Deliveries to equip 4 tank brigades were completed in January 2021. Armament, edit. Primary, edit. M68A1 rifled gun, edit. The main armament of the original model M1 and IPM1 was the M68A1 105mm rifled tank gun firing a variety of APFS, heat, high explosive, white phosphorus rounds and an anti-personnel, multiple flushed, round. This gun used a license-made tube of the British Royal Ordnance L7 gun together with the vertical sliding breech block and other parts of the US T254E2 prototype gun. However, a longer-ranged weapon was always envisaged, with lethality beyond 1.9 mile, 3 kilometers, to combat newer armor technologies. To attain that lethality, the projectile diameter needed to be increased. The tank was able to carry 55 105mm rounds, with 44 stored in the turret blowout compartment and the rest in hull stowage. Being non-combustible, the empty cartridge cases of the M1 variant accumulated on the turret floor after firing. After allowing some time to cool, they were ejected out of the hatch by the loader. M256 smoothbore gun, edit. The main armament of the M1A1 and M1A2 is the M256 120mm smoothbore gun, designed by Rheinmetall AG of Germany, manufactured under license in the US by Waterfly et Arsenal, New York. The M256 is an improved variant of the Rheinmetall 120mm L/44 gun carried on the German Leopard 2 on all variants up to the Leopard 2A5, the difference being in thickness and chamber pressure. Leopard 2A6 replaced the L/44 barrel with a longer L/55. Due to the increased caliber, only 40 or 42 rounds are able to be stored depending on if the tank is an A1 or A2 model. 1 elevation, 9 to plus 20 degree. The M256 fires ammunition with combustible cartridge cases made out of nitrocellulose. The cartridges were safer against premature ignition and flarebacks than earlier combustible cartridge rounds, but not entirely accident-proof. The M256 fires a variety of rounds. The primary APFS round of the Abrams is the depleted uranium M829 round, of which 4 variants have been designed. M829A1, known as the Silver Bullet, saw widespread service in the Gulf War, where it proved itself against Iraqi armor such as the T-72. The M829A2 APFS round was developed specifically as an immediate solution to address the improved protection of the Russian T-72, T-80U or T-90 main battle tank equipped with Contact 5 explosive reactive armor, era. Later, the M829A3 round was introduced in 2002 to improve its effectiveness against next-generation era-equipped tanks. Development of the M829 series is continuing with the M829A4 currently entering production, featuring advanced technology such as data link capability. The Abrams also fires heat warhead-shaped charge rounds such as the M830, the latest version of which, M830A1, incorporates a sophisticated multimode electronic sensing fuse and more fragmentation that allows it to be used effectively against armored vehicles, personnel, and low-flying aircraft. The Abrams uses a manual loader, who also provides additional support for maintenance, observation post /listening post, op/LP, operations, and other tasks. The new M1028 120mm anti-personnel canister cartridge was brought into service early for use in the aftermath of the 2003 invasion of Iraq. It contains 1,098 3/8-inch, 9.5mm, tungsten balls that spread from the muzzle to produce a shotgun effect lethal out to 600 meters, 2,000 feet. The tungsten balls can be used to clear enemy dismounts, break up hasty ambush sites in urban areas, clear defiles, stop infantry attacks and counter-attacks and support friendly infantry assaults by providing covering fire. The canister round is also a highly effective breaching round and can level cinder block walls and knock man-sized holes in reinforced concrete walls for infantry raids at distances up to 75 meters, 246 feet. Also in use is the M908 obstacle reduction round. It is designed to destroy obstacles and barriers. The round is a modified M830A1 with the front fuse replaced by a steel nose to penetrate into the obstacle before detonation. The U.S. Army Research Laboratory, ARL, conducted a thermal analysis of the M256 from 2002 to 2003 to evaluate the potential of using a hybrid barrel system that would allow for multiple weapon systems such as the XM1111 mid-range munition, airburst rounds, or XM1147. The test concluded that mesh density, number of elements per unit area, impacts accuracy of the M256 and specific densities would be needed for each weapon system. In 2013, the Army was developing a new round to replace the M830/M830A1, M1028, and M908. Called the M1147 Advanced Multipurpose XM1147 Advanced Multipurpose, SV, AMP, round. It will have point detonation, delay, and airburst modes through an ammunition data link and a multimode, programmable fuse in a single munition. Having one round that does the job of four would simplify logistics and be able to be used on a variety of targets. The AMP is to be effective against bunkers, infantry, light armor, and obstacles out to 500 m, 1,600 feet, and will be able to breach reinforced concrete walls and defeat ATGM teams from 500 to 2,000 m, 1,600 to 6,600 feet. Orbital ATK was awarded a contract to begin the first phase of development for the AMP XM1147 high-explosive multipurpose with tracer cartridge in October 2015. As of 2024, the round is undergoing the final testing stages, with the full-rate production decision scheduled for the end of the year. In addition to these, the XM1111 mid-range munition chemical energy was also in development. The XM1111 was a guided munition using a dual-mode seeker that combined imaging infrared and semi-active laser guidance. The MRMCE was selected over the competing MRMKE, which used a rocket-assisted kinetic energy penetrator. The CE variant was chosen due to its better effects against secondary targets, providing a more versatile weapon. The Army hoped to achieve IOC with the XM-1111 by 2013. However, the mid-range munition was cancelled in 2010 along with future combat systems. Secondary, edit. The Abrams tank has 3 machine guns, with an optional 4th. 1 .50 cal. 12.7 mm, M2HB machine gun in front of the commander's hatch. On the M1 and M101, this gun is mounted on the commander's weapons station. This allows the weapon to be aimed and fired from within the tank. Normal combat loadout for the M101 is a single 100-round box of ammo at the weapon, and another 900 rounds carried. The later M102 variant had a flex mount that required the tank commander to expose his or her upper torso in order to fire the weapon. In urban environments in Iraq, this was found to be unsafe. With the Common Remote Operated Weapons System, CROWS, add-on kit, an M201.50 caliber machine gun, M240, or M249 saw can be mounted on a CROWS remote weapons platform, similar to the Protector M151 remote weapons station used on the Striker family of vehicles. Current variants of the Tank Urban Survival Kit, TUSK, on the M102 have foregone this, instead adding transparent gun shields to the commander's weapons station. The upgrade variant called the M101 Abrams Integrated Management, AIM, equips the .50 caliber gun with a thermal sight for accurate night and other low visibility shooting. To a 7.62 mm M240 machine gun in front of the loader's hatch on a skate mount, seen at right. Some of these were fitted with gun shields during the Iraq War, as well as night vision scopes for low visibility engagements and firing. This gun can be moved to the TC's position if the M2.50 cal is damaged. 3 a second 7.62 mm M240 machine gun in a coaxial mount, i.e., it points at the same targets as the main gun, to the right of the main gun. The coaxial MG is aimed and fired with the same computerized firing control system used for the main gun. On earlier M1 and M101s 3,000 rounds are carried, all linked together and ready to fire. This was reduced slightly in later models to make room for new system electronics. A typical 7.62 mm combat loadout is between 10,000 and 14,000 rounds carried on each tank. 4. Optional, a second coaxial .50 cal. 12.7 mm, M2HB machine gun can be mounted directly above the main gun in a remote weapons platform as part of the XAM, Counter-Sniper Anti-Material Mount, package. Aiming, edit. The Abrams is equipped with a ballistic fire control computer that uses user and system-supplied data from a variety of sources to compute, display, and incorporate the 3 components of a ballistic solution: lead angle, ammunition type, tube wear, propellant temperature, wind speed, air temperature, the relative motions of the target and the Abrams, and range to the target, to accurately fire the main gun. These 3 components are determined using a laser rangefinder, crosswind sensor, a pendulum static cant sensor, data concerning performance and flight characteristics of each specific type of round, tank-specific boresight alignment data, ammunition temperature, air temperature, barometric pressure, a muzzle reference system, MISIS, that determines and compensates for barrel drop at the muzzle due to gravitational pull and barrel heating due to firing or sunlight, and target speed determined by tracking rate tachometers in the gunner's or commander's controls handles. All of these factors are computed into a ballistic solution and updated 30 times per second. The updated solution is displayed in the gunner's or tank commander's field of view in the form of a reticle in both day and thermal modes. The ballistic computer manipulates the turret and a complex arrangement of mirrors so that all one has to do is keep the reticle on the target and fire to achieve a hit. Proper lead and gun tube elevation are applied to the turret by the computer, greatly simplifying the job of the gunner. The fire control system on the M1 and M1A1 variants is the Computing Devices Canada Ballistic Computer System. On the M1A2 the fire control electronics unit is manufactured by GDLS. The laser designator is a Hughes model. A 2nd Armored Cavalry Regiment soldier assisting in the critical job of bore sighting the alignment of all the tank's sights to the center of the axis of the bore of the main gun on an M1A1 Abrams in Mosul, Iraq, in January 2005. The fire control system uses this data to compute a firing solution for the gunner. The ballistic solution generated ensures a hit percentage greater than 95% at nominal ranges. Either the commander or gunner can fire the main gun. Additionally, the commander's independent thermal viewer, SIDV, on the M1A2 can be used to locate targets and pass them on for the gunner to engage while the commander scans for new targets. If the primary sight system malfunctions or is damaged, the main and coaxial weapons can be manually aimed using a telescopic scope bore sighted to the main gun known as the gunner's auxiliary sight, GAS. The GAS has 2 interchangeable reticles, one for heat and multipurpose anti-tank, BAT, ammunition and one for AFSTs and smart target activated fire and forget, staff, ammunition. Turret traverse and main gun elevation can be performed with manual handles and cranks if the fire control or hydraulic systems fail. The commander's M2HB.50 caliber machine gun on the M1 and M1A1 is aimed by a 3 magnification sight incorporated into the commander's weapon station, CWS, while the M1A2 uses the machine gun's own iron sights, or a remote aiming system such as the Common Remotely Operated Weapon Station, CROWS, system when used as part of the Tank Urban Survival Kit. The loader's M240 machine gun is aimed either with the built-in iron sights or with a thermal scope mounted on the machine gun. In late 2017, the 400 USMC M1A1 Abrams were to be upgraded with better and longer range sights on the Abrams Integrated Display and Targeting System, ADATS, replacing the black and white camera view with a color sight and day forward/night thermal sight, simplified handling with a single set of controls, and a slew to Q button that repositions the turret with one command. Preliminary testing showed the upgrades reduced target engagement time from 6 seconds to 3 by allowing the commander and gunner to work more closely and collaborate better on target acquisition. Mobility, edit. Tactical, edit. See also, AGT 1500. The M1 Abrams' powertrain consists of an AGT 1500 multi-fuel gas turbine, originally made by Lycoming, now Honeywell, capable of 1,500 shaft horsepower, 1,100 kilowatts, at 30,000 RPM and 395 pound-foot, 536 Nm, at 10,000 RPM and a 6-speed, 4 forward, 2 reverse, Allison X1100-3B hydrokinetic automatic transmission. This gives it a governed top speed of 45 miles per hour, 72 kilometers per hour, on paved roads, and 30 miles per hour, 48 kilometers per hour, cross-country. With the engine governor removed, speeds of around 60 miles per hour, 97 kilometers per hour, are possible on an improved surface. However, damage to the drivetrain, especially to the tracks, and an increased risk of injuries to the crew can occur at speeds above 45 miles per hour, 72 kilometers per hour. The tank was built around this engine and it is multi-fuel capable, including diesel, gasoline, marine diesel and jet fuel, such as JP4 or JP8. In the AGT 1500, jet fuel has poorer fuel economy and operating range compared to diesel. By 1989, the Army was transitioning solely to JP8 for the M1 Abrams, part of a plan to reduce the service's logistics burden by using a single fuel for aviation and ground vehicles. However, as of 2023, the U.S. Army frequently refuels the Abrams with diesel, which is also used by the Bradley fighting vehicle. The Australian M1A1 AIMSA burns diesel fuel, since the use of JP8 is less common in the Australian Army. The gas turbine propulsion system has proven quite reliable in practice and combat, but its high fuel consumption is a serious logistic problem. The engine burns more than 1 point.
Yes. The camcorder is out of power. Now it's 11:20. So the local pizza shop is open 11 a.m. So go down shopping a bit, a little, maybe eat a pizza, kebab or pizza. And the sun is shining now, the temperature will get up slowly. Now it's 26. It will get up to 30. So I will stop the video and charging, then I'll read when I get back later. I made a payment today, this credit. I'm waiting for payment, this 30-day credit. I'll have to check later.